Hello guys, welcome back to the channel Mathemagix JEE. This is part of the CBQ series or the concept building question series where we are going to solve specific problems to build our thinking capability for JEE Advanced. As always, I would recommend you to pause the video and attempt the question yourself before seeing the solution. So let's start our discussion. Here it is saying the number of natural numbers n less than equal to 2025 for which the following equation nc1 sin x plus nc2 sin 2x plus nc3 sin 3x plus so on up to ncn sin nx is equal to 1 plus nc1 cos x plus nc2 cos 2x plus so on up to ncn cos nx holds true for x equal to pi by 6. Okay, so we have to calculate the total number of natural numbers less than equal to 2025 which satisfies this equation when x is equal to pi by 6. Now to determine the values of n, we need to first solve this equation. That means we have to determine LHS and RHS separately. See, there are binomial coefficients NC1, NC2, NC3 and so on up to NCN involved in this question. That means there may be use of binomial theorem in this problem. But how to proceed? Let's discuss about what will be our approach when we see this type of questions. For example, we see here this cos function has argument x here, okay? And here this same argument x is inside sine function. Now, whenever we see similar type of arguments inside a cosine function and a sine function, there is a special type of approach that we should remember that may help us in solving special type of series. So let us call this left hand series as P and right hand series as Q. So P is this series summation NCR sine Rx, and Q is this series 1 plus summation R equal to 1 to N NCR cos of Rx. Now, the idea that should strike our mind whenever we see this type of questions is that this cos and sine will correspond to real and imaginary part of a complex number. Why? Because let's say we have a complex number r e to the power iota theta. Then it can be written as r cos theta plus r iota sine theta or iota times r sine theta by Euler's formula. That means if somehow we can express this p and q, or more specifically q minus 1, as the real part and imaginary part of a complex number, then we can represent this series in the form of some series in complex numbers. For example, if I take these two series here, let's say p is our imaginary part. So I write iota times p and plus real part of this series is q minus 1. So q minus 1. Q minus 1 plus iota p is this summation r equal to 1 to n, then ncr, then it will become cos rx plus iota times sine rx, like this. Now we can write this cos rx plus iota sine rx as e to the power iota rx. So we can write this right hand side as summation r equal to 1 to n, then ncr. Now this can be written as e to the power iota x whole to the power r. This is the important manipulation you need to note down. So this series is nothing but the binomial series. That means this can be written as 1 plus e to the power iota x whole to the power n. And there is one term missing. What will be that term? That term will be nc0 e to the power iota x whole to the power 0. That means minus 1. So we can write this q minus 1 plus iota times p as 1 plus e to the power iota x whole to the power n minus 1. Now how to expand this? This 1 plus e to the power iota x, let us expand this one first. So we can write this as 1 plus cos x, this is the real part, and plus iota times sine x. Now this thing can be written as 1 plus cos x, we can write as 2 cos square x by 2 plus iota times this sine x, we can write as 2 sine x by 2 cos x by 2. Now we can take this cos x by 2 and 2 common, so it will become 2 cos x by 2 times cos x by 2 plus iota times sine x by 2. So we can write this one as 2 cos x by 2 into e to the power iota x by 2. Now if we substitute this here, we will get this 1 plus e to the power ix, we can write as 2 cos x by 2 times e to the power I x by 2 whole to the power n minus 1. That means it will become 2 cos to the power n, sorry, it will become 2 to the power n, then cos x by 2 whole to the power n times e to the power iota n x by 2 minus 1. So we can again expand this e to the power iota nx by 2 as cos nx by 2 plus iota sine nx by 2 minus 1. That means we can separate the imaginary part and real part of this right hand side. So it will become 2 to the power n cos to the power n x by 2, then cos nx by 2 minus 1 plus iota times 2 to the power n cos to the power n x by 2 times sine of n x by 2. Now we can compare the real part and imaginary part of both sides. That means we can write that q minus 1 should be equal to 2 to the power n cos to the power n x by 2 cos nx by 2 minus 1, and p is equal to 2 to the power n cos to the power n x by 2 sine nx by 2. So this q will become this and p will become this. Now our question says that we have to find the value of n for which this p is equal to q. That means p equal to q gives us this 2 to the power n cos to the power n x by 2 cos nx by 2 is equal to 2 to the power n cos to the power n x by 2 sine nx by 2. This equation holds when x is equal to pi by 6. So we can write this as 2 to the power n times cos to the power n x by 2 will become pi by 12, then cos, this will become n pi by 12 is equal to 2 to the power n cos to the power n pi by 12 times this will be sine of n pi by 12. Now here in this equation we can cancel these two terms. Why? Because 2 to the power n is not 0 and cos to the power n pi by 12 is non-zero, because cos pi by 12 is non-zero. So we can cancel from both sides and we can say that this trigonometric equation is nothing but tan n pi by 12 is equal to 1. So we have to find the number of solutions of this equation in 1 to 2025. Now how to find the solutions? We can use the general form of solution of a trigonometric equation. That means we can use that this 1 can be written as tan of pi by 4. So this equation is nothing but n pi by 12 is equal to pi by 4 plus k pi, where k is an integer. So we can find the value of n from here. N will be equal to 3 plus 12k. Now we can see easily that n equal to 3 will be a solution when we put k equal to 0. K equal to minus 1 we cannot put because 3 minus 12 will be negative, and n is a natural number because n should be such that the binomial coefficient is defined. So n cannot be less than 0. Now how many solutions exist? So we can put this 3 plus 12k to be less than equal to 2025. So this 12k should be less than equal to, this will be 2022. So k should be less than equal to 2022 divided by 12. So that means that comes out to be, if you calculate, it will be 168 point something. Now we know that k is an integer. So k max, which is the maximum possible value of k, will be 168. That means we have the solutions k equal to 0, 1, 2, so on up to 168. There are total 169 values of k possible, for which n is a natural number and n is less than equal to 2025. For each value of k here, we will get a corresponding n which will satisfy the given equation. So we can say the correct answer of this question will be 169. I hope you understood the concept behind this problem.